In topic 3, we're going to look at solving systems of equations using the substitution method. So this is one of the algebraic methods. You could certainly use graphing, the method we learned in the previous video, to check your solution here, but please understand on tests, quizzes, any kind of activity like that, I want to see the algebra, okay? So you could certainly use Desmos to check a result, but you need to show me your work otherwise. All right. So this method involves converting the system to one equation and one variable by using substitution. Okay. So how do we do this? Well, there are 5 basic steps. Okay. So the first thing you want to do is you want to take one of the 2 equations and solve that equation for one of the 2 variables. Okay. Now you could take either equation and you could solve for either variable. Okay. However, be kind to yourself. Look for an equation and a variable that has a coefficient of 1 or -1. That's always going to be the easiest one to solve for. So start with equation that has a variable with a coefficient of 1 is your best case, -1 is your second best case. Okay, so if you have an equation that has a variable with a coefficient of 1 or -1, that's the one you need to solve for. Okay, now what you do once you solve that equation for that variable, substitute the result from step 1 into the opposite equation. Okay, so if you solve the first equation for x, you want to take the value for x and plug it into the second equation. That's why we call this the substitution method. Okay, now once you have substituted, you want to solve, okay, because that's going to create an equation in one variable that you can then solve. All right, and then you take the result from step 3 where you solve. So you're going to get either an x coordinate or a y coordinate, depending. You're going to take that result, plug it into either of the original equations to find the second variable. Okay, so you kind of substitute twice. Okay, so I think if we start with just words, it can be a little confusing, but if you can see this process worked out, it makes the steps written out in words make a bit more sense. Okay. So example 3 says, solve each system of linear equations using substitution. Write the answer as an ordered pair. Okay, so for part A, we have the system 2x minus 3y equals -13. And then we have y equals 2x plus 7. This is going to be a really easy example because we don't have to do step 1. So if we go back here to step 1, it says solve one equation for one variable. Well, if we look at the second equation, it has already been solved for y. So let's just use that as our substitution, okay? So what this means is I'm going to take this value for y. We're saying y equals 2x plus 7. And I'm going to plug it into the other equation for y, okay? So I've got 2x minus 3y, but we're saying that y is 2x plus 7, and then that equals -13. So hopefully you can see in blue that substitution. So that second equation was already solved for y. The value for y was 2x plus 7. We take 2x plus 7 and plug it into the first equation for y. And now if we look at this line right here, we have a single equation with a single variable, and we can use what we learned in chapter 6 to solve this, okay? So to solve a regular linear equation in one variable, the first thing we would want to do is see if we can remove parentheses by distributing, and we do have a set of parentheses. So I'm going to start by just dropping down my 2x, and then that -3 in front of the blue set of parentheses, I need to distribute that. So -3 times 2x is -6x. -3 times +7 is -21, and that all equals -13. Okay, so once you distribute, you want to see if you can combine like terms on the left or on the right. The left-hand side, we can definitely simplify. So 2x minus 6x is -4x. And then I'm going to keep my -21 and my equals -13. Okay, now I've got all of my variables in a single term. I need to isolate that term, so I need to get the -4x alone. The -21 is the issue. To move 21, I would add it to both sides. Well, -21 plus itself is just 0, leaving me with -4x on the left. And then on the right, we get, let's see, 7 plus 1, we get 8. So -13 plus 21 is 8. And then finally, we need to undo the multiplication of -4 and 8. So I divide both sides by -4. The -4s, we would get lazy and say they cancel. Just know that when we divide them, we get 1. And 1 times x is just x. And then 8 divided by negative 4 is negative 2. Now remember, the solution to a system of equations is an ordered pair. And right now we can say, hey, the ordered pair has an x coordinate of negative 2. But how in the world do we find the y coordinate? Well, we want to take this value for x and plug it into either of the original equations. It does not matter which one. So I think I'm going to take this value for x and plug it into the second equation for x, okay? So that would give me y equals 2 times x, but x is negative 2, plus 7. Well, 2 times negative 2 is negative 4. And negative 4 plus 7 is 3. So we would then say, well, x is negative 2, y is 3. That's going to be the solution to our system. But remember, solutions to systems of linear equations in two variables are ordered pairs. So we want to write our final answer as an ordered pair. So this right here with stars beside it, that is our solution. And if you wanted to check your work, you absolutely could. You could take this ordered pair, plug it into both equations, and if that ordered pair satisfies both equations, you have been able to verify your answer. You could also type both of these equations into Desmos and double check the point of intersection. Okay? Now let's look at part B. So part B, we don't have an equation that has already been solved for a variable. However, we do have an equation that has a coefficient on one of the variables that is either 1 or in this case, negative 1. That is always where you want to start. It's going to be the easiest. So what we're going to do is we're going to solve the first equation for x, okay? Now how you go about solving for x is up to you. So I've got negative x plus 3y equals 10. I want to isolate my x, so I'm going to subtract 3y from both sides. 3y minus 3y is 0, leaving me with just minus x equals negative 3y plus 10. And then we haven't officially solved for x until we have a single positive x on the left, so I want to divide all terms by negative 1. So I get that x equals 3y minus 10. When you divide terms by negative 1, it just changes all of your signs. So we now have that x equals this right here. X equals 3y minus 10. And what I want to do is I want to take this value for x and plug it into the other equation for x. So I'm going to plug it into the second equation for x. Okay? So when I do that, my second equation is going to be 2 times x, which is 3y minus 10. And then we just rewrite the rest of the equation. So plus 8y equals negative 6. All right. And now we want to solve the equation because by doing this substitution, we have an equation in one variable. This is something we can solve for. So we would take 2 times 3y. We need to distribute first. 2 times 3y is 6y. 2 times negative 10 is negative 20. We want to add 8y equals negative 6. So just rewrite the rest of the equation. If you can simplify or combine like terms on either side, you would do so, and we can on the left. So we have 6y plus 8y, that's 14y, and then we still have minus 20 equals negative 6. I've got all of my variables in a single term. I want to isolate that term. So I want to isolate the 14y by adding 20 to both sides. So negative 20 plus 20 is 0. That leaves me with just 14y equals, well, negative 6 plus 20 is 14. I need to undo the multiplication of 14 and y, so I would divide both sides by 14. On the left, 14 divided by itself is 1. 1 times y is y. And then again, 14 divided by itself is 1. So remember, the solution to a system of equations is always an ordered pair. Okay, so a system of equations, two variables, you get an ordered pair. We're saying now that y has to be 1, we need to figure out what x is. So we take this value for y, and you can plug it into either of the original equations for y to figure out what x is. So I could plug it in here for y. I'm going to plug it into the second equation for y. So we get 2x plus 8y, and we're saying that y is 1. And that's all going to equal negative 6. So let's see, I get 2x plus 8 equals negative 6. I want to isolate my two x's. I need to move the 8. I do that with subtraction. 8 minus 8 is 0, so I get 2x plus 0 is just 2x. And then on the right, negative 6 minus 8 is negative 14. I need to undo the multiplication of 2 and x. So I would do that with division. Divide both sides by 2. 2 divided by itself is 1. 1 times x is x. And then negative 14 divided by 2 is negative 7. So there is the x coordinate of our ordered pair, and we do want to go ahead and write our final answer as an ordered pair. That is absolutely how you represent your answer to a system of equations. All right, so we would say negative 6, comma 1. This right here with stars beside it, that is our solution. So please do write your answer as an ordered pair. If you leave it y equals 1, x equals negative 7, to me that looks like you're saying you have a horizontal equation that crosses the y-axis at 1 and a vertical line that crosses the, wait, what did I say? We have the equation y equals 1, which looks like a horizontal line that crosses the y-axis at 1. And then x equals negative 7 looks like a vertical line that crosses the x-axis at negative 7. So please write your answer in the right format, which would be an ordered pair. Okay, so that is solving systems of equations using the substitution method. In the next video, we will look at the addition method, which is also sometimes called the elimination method. Okay, I am fine if you call it either one. All right.